Today we talked about transformations of quadratic functions using vertex form, which is this equation right here. We talked about two things, the k value and the h value. So we're going to start with just a quick recap about the k value. The k value is your shifts up and your shifts down. So you have two options if your k is a number. It can either shift up k units, so if k was 4, then 4 units, or you can shift down k units. Remember, k is just a variable, just a placeholder for a number. It shifts up if your k is positive. So if you see plus something at the back here, like plus 2, plus 4, plus 20, whatever it may be, and it's going to shift down if k is negative. So if you see minus 4, minus 5, minus 24, if you see minus, then k is negative. If you see plus, then k is positive. So on these ones, it just wants you to identify the transformation and the vertex. For right now, we haven't talked about going left and right, so our x value of the vertex has been 0. So this is my k. It's positive, so that tells me that I'm going up 5 units, which would put my vertex at 0, 5, because our vertex starts at 0, 0 for the parent function, and then it's going up, so it only impacts the y value. Number 2, our k is negative 3, which tells us that we are going down 3. So my vertex is at 0, negative 3. On the graphs, we're doing the same type of thing. My vertex here is at 0, 4. And on this one, my vertex is at 0, negative 3. And when you're describing the transformations, remember that your parent function has a vertex at 0, 0, and is U-shaped from there. So it doesn't have to be a perfect little sketch, just wanted to kind of help you. Ooh, I didn't even make the dot. There we go. So if I'm starting here at my parent function, and this is my new function, then it is going up. And it's going up 1, 2, 3, 4 units. Whereas the second one is starting at 0, 0, and it's going down 1, 2, 3 units. Then it wants you to write an equation, so kind of like the opposite of what we did up here. If it shifts up 8 units, then our k is positive 8. And then for ones that shift down, your k would be negative. So that is the k value, up and down. Then we talked about, we did exploring the h value, and then we talked about the h value. So again, full copies of everything we did are on the notes key under the classwork for each day. This is just kind of like a summary. So the h value is what we're talking about now, and that is your shift left and your shift right. And we had you guys write this little note at the top of your paper. I don't know why I keep saying Unit 9 on my copy. Here said Unit 11, which is what we're in. So in our formula, it's x minus h, which is really important. So we did a couple examples. We did x minus negative 1, and we did x minus a positive 1. When you subtract a negative, that's the same thing as adding a positive. So x minus a negative 1 is really just x plus 1. And when you subtract a positive, that's just subtracting. So x minus a positive 1 is just x minus 1. So you shift left when your h is negative, which should make sense to you guys, because if you think about the x and y axis, or the x-axis, because we're going left and right, your negative numbers are on the left and your positive numbers are on the right. So you're going to shift left if it's negative and shift right if it's positive. But if I look up here, if I'm subtracting a negative, in my actual equation it's going to look like addition. So we also added this note that you're going to see an addition sign in the problem. And when h is positive, like here, when you're subtracting a positive one, it's just going to look like subtraction. So you're going to see subtraction. This is the part that is definitely the most confusing. So if we look at this, x minus 4, that's the same as x minus positive 4. So positive 4 is your h. Since h is positive 4, that tells you that we are going right 4 units. Again, the vertex is starting at 0, 0. We're going left and right, so our vertex this time would end up at 4, 0. Then on this one we have plus 6, but we always want to think in terms of subtraction. So adding is the same thing as subtracting a negative. So that's how we know that it's negative here. Anytime you see addition, you need to think that's subtracting a negative. So this is telling me that we would go left 6. Same thing as before over here. You always want to think about your parent function starting at 0, 0. Sometimes they're not a very good view, but just a general idea. My vertex for my new graph is over here at negative 2, 0. My vertex on this one is at 5, 0. This one has moved to the right 5. And this one has moved to the left 2. And then we also talked about writing equations. So again, kind of like the opposite of this. It's going to tell us what the transformation is, and we have to write our form, or write our equation. So if we are going to the right 8 units, that means our h is a positive 8, because it's going to the right, that's positive numbers over there on the axis. So we'd have y is equal to x minus a positive 8 squared. We're not going up or down, so I don't need anything at the back. Subtracting a positive is just the same thing as subtracting. Whereas when we go to the left, then our h is negative. And when we write our formula, we would have x minus h. So x minus negative 20 minus the negative becomes plus. And the last thing we did was we kind of put everything all together. So if we remember, we're going to have a times x minus h squared plus k. We didn't talk about a yet. We're going to get to that tomorrow. Today was just all about h and k. So if I look at this, x minus 2, that's x minus a positive 2. So that's my h is a positive 2. And my k is a positive 4. If h is positive 2, that tells me that we are going right 2 units. And if k is positive 4, that tells me that we are going up 4 units. So again, inside the parentheses, you always want to think in terms of what are you subtracting. So here, x plus 3, well, I want to think of that in terms of subtracting, so that's x minus negative 3. So there's my h, negative 3. My k is out back. So if h is negative 3, that tells us that we are going left 3 units. K is negative 2. That tells me we are going down 2 units. Right, now in these ones we are going to describe the transformation and name the vertex and create an equation. So I know my parent function starts at 0, 0. And it's moving all the way over here. So it is going to the right 1, 2, 3, and is also going up 1. So we are going right 3 units 1 unit. The new vertex is at 3, 1. If we are going right 3, that means our h is positive 3, and if we're going up, that means our k is a positive 1. We would have y is equal to x minus a positive 3 squared plus 1. Minus a positive is just the same thing as subtracting. I didn't mean to put that there. That would be our final answer. Alright, so I'm going to do just a couple more. If we are going up 4 units, then our k is positive 4. Left 3, our h is negative 3. We would have x minus negative 3, because x minus h plus k. Remember, you can't have that minus a negative in there. Minus a negative is the same thing as adding. And over here, if we're going right 5 units, our h is positive 5. Down 2, our k is negative 2. So we'd have y is equal to x minus a positive 5, because that's positive 5, minus 2. Minus a positive is the same thing as just subtracting. Alright, so that was all we did yesterday. We just focused on h and k. H is definitely the part that was tripping you guys up the most. So remember, you always want to think in terms of subtracting.